Professor Pelton. This is Algebra 2, Chapter 6, Section 5. This is part 2 of the video. We're going to use the properties of logs to expand the following expressions completely. So the two things we're going to do is expand and condense in this section to help us solve equations later on. So there is an order of operations or order of rules here. So I get my marker to turn on here. Oops. Here's an order of expansion. So if there is multiple rules to apply, you must do the quotient rule, the product rule, and then the power rule of logs. It must happen in that order for expansion if there are multiple of them. So the first one is just a product. So that's common log, which that's log base 10 basically. And log base x, because if it's a multiplication, it's actually addition. So we know this is actually base 10 if it's a common log, correct? Is none specified. So that's the first power. So that actually cancels and leaves us with 1 plus log base 10 of x. You should always simplify whenever possible for any cancellations. Okay, next one is a quotient rule. So this is the natural log of e to the third minus the natural log of 7. But natural log is log base e. So essentially those cancel by definition. So we're left with 3 minus the natural log of 7. Okay, the next one, doesn't appear there's anything to do here, but if you rewrite this, this is actually log base 3 of x to the 1/2, because that's what a square root is. So I can do the power rule of logs and bring down that 1/2. So it's 1/2 times log base 3 of x. Okay, so the next one is our first one that actually has multiple things to do. There is no quotient in this one, but there is a product right there. So this is log base b of x squared plus log base b of the square root of y. So then we do the power rule last. So this is 2 times log base b of x. And remember, this square root of y is actually y to the 1/2, right? It's the same thing. So that's plus 1/2 log base b of y for our final answer. Okay, let's scroll down to letter E. So letter E is going to involve all three rules. So if you remember the order, quotient rule must happen first. So this is log base 6 of the third root of x minus log base 6 of 36. Not 30y, 36. What am I doing? 36y to the fourth. Okay. And then the product rule must happen for second. So that's log base 6 of the third root of y is really x to the 1/3. I'll just rewrite that for now. Can't make it 1/3 very well. Try that again. 1/3, right? Minus log base 6 of 36 plus log base 6 of y to the fourth. And this is actually wrong. So yes, we did do the product rule. Okay, the product rule says break it up, correct, if it's a multiplication into an addition, but that subtraction goes to the whole thing. So there needs to be brackets right here to distinguish the fact that there is brackets throughout. Okay, so now we'll do a simplification step. You know, I'll keep this as the root 3. So we'll just do some simplification now, which is not one of the things, but you always should simplify first. This is log of x to the 1/3 base 6 minus log base 6. I'm not making very good thirds today. I don't know why. Okay, 36 is 6 squared minus log base 6 of y to the fourth. Okay, so we did some simplifying, distributed the negative and got rid of the radicals into exponents. Now we can do the power rule last. So we have 1/3 times log base 6 of x minus, these cancel, leaving me with a 2. And I have minus 4 times log base 6 of y. So that is our final answer. Pause the video, try the student problems for yourself. Okay, so we have a product rule, log 100 plus log of x, but again, this is common log since no base is specified. So if I really think about what I have here, I have really log base 100, base 10, and 100 is actually 10 squared. So those cancel, leave me with 2 plus log of x is our final answer. All right, next one is a quotient rule of logs. So we have log base 8 of 64 minus log base 8 of x, which is log, um, equals. So 64 is really 8 squared. So those cancel, leave me with a final answer of 2 minus log base 8 of x. Okay, next one has a couple different things here. So you could distribute the exponent first if you wanted to, and do 4 to the fifth and x to the fifth. It really doesn't matter. Okay, so essentially if I do the power rule, I'm sorry, the product rule first, I would get log base 6 of 4 plus log base 6 of x, but that 5 goes to both. Okay, so it needs to go out front. So that's 5 times log base 6 of 4 plus 5 times log base 6 of x. A couple different ways to do that. You can also just put the 5 down there first and distribute to both. Either way is sufficient. Okay, let's move this down for D and E. Okay, so remember for expansion, the order matters. So quotient rule first, but there isn't one in this case, but there is a product. So log base b of x to the fourth plus log base b of the third root of y. So quotient rule first, which there wasn't one, product rule, then power rule. So this is really 4 times log base b of x using the power rule of logs. Plus, this is really y to the 1/3 if you think about it, right? So this is 1/3 times log base b of y. So that is our final answer there. Okay, next one. This has all three. Quotient rule must come first. So log base 5 of the root x minus log base 5 of 25 y to the third. So quotient rule first, so then product rule. Log base 5 of root x minus log base 5 of 25 plus log base 5 of y to the third. But again, this is wrong because that negative must go to both terms because that negative applied to the whole log, didn't it? Right? So now we can do some simplification first before we do the last step, which is the power rule of logs. So this is really log base 5 of x to the 1/2. Distribute the negative. I have log base 5. 25 is 5 squared. Distribute the negative, and I have log base 5 of y to the third. So final answer using the power rule is 1/2 times log base 5 of x. These cancel, leave me with a 2. And lastly, 3 times log base 5 of y is our final answer. Okay, that is the end of part 2.